Hi everyone, this is the second lesson for our topic of surface area, and in this lesson we're going to look at the surface area of prisms. So in our first lesson we reviewed the area of plane shapes. We looked at the area of squares and rectangles, and then triangles, then the other quadrilaterals, and then finally circles and sectors. So we've learnt about the area of two-dimensional shapes, but if we want to find the area of a three-dimensional shape, then it's called the surface area. So if we want to calculate the surface area of a prism, we need to find the individual areas of all of the faces and then add them together. So the first thing we need to find out is how many faces does it have and what shape are they? So this is a rectangular prism and it has 6 faces and they're all rectangles, but we can actually group them in pairs. The top and the bottom rectangles are the same, the 2 side rectangles are the same, and the front and the back rectangles are the same. It might help to sketch the net of a prism to help you visualize the different faces. So this rectangular prism, this is its net. We can see the front and back rectangles, the top and bottom rectangles, and the 2 side rectangles. So it really is the edges of a prism that are important for calculating surface area. This rectangular prism has 12 edges and they measure either 3 centimeters, 5 centimeters, or 10 centimeters. So let's see if we can match them with the faces. So we'll start with the top and the bottom. The edges that go with the top and the bottom are 3 centimeters and 10 centimeters. With the 2 sides, the edges are 3 centimeters and 5 centimeters. And with the front and the back, the edges are 10 centimeters and 5 centimeters. So let's calculate the areas of each face. We're going to start with the top and the bottom rectangles. So remember that the area of a rectangle is its length times breadth, so 10 times 3. And then we're going to do 2 lots of that because the top and the bottom rectangles are both the same. So we can do 2 lots of 10 times 3, which is 60 centimeters squared. Now the side rectangles, the area is going to be 3 times 5, and we've got 2 of them. So 2 lots of 3 times 5 is 30 centimeters squared. And then finally the front and the back rectangles. The front rectangle is 10 by 5, so 50, and then we're going to double it. So that's going to give us 100 centimeters squared. Now you can't stop there, we've got to actually add all of these together. So TSA stands for total surface area, and it's going to be 60 plus 30 plus 100, which gives us 190 centimeters squared. Now there is a formula that can be used to calculate the total surface area of a rectangular prism, and there it is there. It's 2 lots of the length times the breadth plus the length times the height plus the breadth times the height. Let's check it out with that previous question. So instead of L we're going to put 10, instead of B we're going to put 3, and instead of H we're going to put 5. And putting it into the calculator, we do get the same answer, 190 centimeters squared. It's up to you whether you want to memorize a formula just for a rectangular prism. That's one option, or you can just take any prism and break it up into its separate faces and find the area of each face. Okay, let's try another one. This one's a triangular prism. So we're going to start with how many faces are there? There are 5. So we've got the front and the back, the 2 sides, and 1 bottom. What shapes are they? Well, we have the 2 triangles, and they're going to be identical. We've got a bottom rectangle, and we've got 2 rectangular sides, which are equal because this is an isosceles triangle. Let's see how we go. So we're going to calculate the area of each shape. We'll start with the triangles. So the area of a triangle is a half times the base times the height. Half times 6 times 4, but there are 2 of them. So I'm going to do 2 lots of half times 6 times 4, which is 24 centimeters squared. Now let's do the bottom rectangle. There's only one of those. 6 times 8 is 48 centimeters squared. And then finally the 2 rectangular sides. So they're going to be 5 times 8, which is 40, and we're going to double it. So that's 80 centimeters squared. So our total surface area is going to be 24 plus 48 plus 80, which is 152 centimeters squared. Now when you set out a question like this, make sure you give lots of working out, and your final answer, make sure you include the units. Now, to find the side length for a triangular prism, we may need to use Pythagoras' theorem. Have a look at this question. How many faces are there? There are 5. What are the shapes? Well, there's a triangle front and back, and they're going to be equal, aren't they? Then there is the bottom rectangle, there's a left-hand side rectangle, and then there's a right-hand side rectangle. Okay, let's see what we can work out. Start with the triangles. Area of a triangle is a half times the base times the height, and we have 2 of them. So that's 2 times a half times 3 times 4, which is 12 centimeters squared. The bottom rectangle is 3 times 3.5, which gives us 10.5 centimeters squared. The left-hand side is 4 times 3.5, which is 15 centimeters squared. And then finally the right side is going to be 3.5 times, don't know. But that's okay, we can use Pythagoras' theorem to work out that edge length. So let's set up Pythagoras' theorem here. X squared is equal to 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to 25. And so x is the square root of 25, which is 5. And now that we know that, we can continue working out our surface area. So the right side is going to be 3.5 multiplied by 5, which is 17.5 centimeters squared. So our total surface area is 12 plus 10.5 plus 15 plus 17.5, which is 55 centimeters squared. Let's finish off with a practical problem. Pete is painting the walls in this room. The window, which is 2.1 meters by 1.8 meters, and the door, which is 2.4 meters by 0.9 meters, do not require painting. What is the total area to paint? So here's the dimensions down here, and we need to be careful because it says that he's painting the walls. He's not painting the ceiling or the floor. So all we need to do is the side rectangles and the front and the back rectangles. Let's look at the calculation. So we want 2 lots of 3 times 2.8. So that's these walls here. And then we want to add 2 lots of 3.5 by 2.8. And so that's 3.5 by 2.8, that's the front and the back. In the calculator we get 36.4 meters squared. Now we need to subtract the window and the door. So the window is a rectangular window, so 2.1 multiplied by 1.8, and the door is also rectangular, so 2.4 multiplied by 0.9, and that will give us 30.46 meters squared. Now 1 litre of paint covers 10 meters squared, and Pete's going to do 2 coats. So let's calculate how many litres of paint he's going to need. We're going to start by doubling this area because of the 2 coats. So he's going to have to paint 60.92 meters squared of wall space. Now we need to know how many tens go into that, which is a division question. So 60.92 divided by 10, we need 6.092 litres. Paint can be purchased in the following amounts: a 1 litre tin for $27 or a 4 litre tin for $68. To save money, what should Pete buy? Now the problem that Pete has is that he needs slightly over 6 litres, which means that he's going to have to buy 7 litres minimum. If he buys a 4 litre tin and 3 1 litre tins, then he's going to pay $149. But if he buys 2 4 litre tins, he only pays $136. So he should buy 2 4 litre tins. Okay, that brings us to the end of this lesson. In our next lesson, we're going to look at the surface area of pyramids.